Okay, next up is for the sensitivity analysis for the tutorial 3 here. So basically, the sensitivity analysis, we calculate this or we analyze this thing when we want to check whether a project is sensitive, the feasibility of a project is sensitive to if the factors influencing it is changed. For example, uh, the interest rate or maybe the investment costs and so on. Okay. So this is an analytical tool to determine the feasibility of an investment decision when the factors or calculation parameters are changed. And then the decision is considered sensitive if any change in the value of a parameter or calculation factor will alter the investment decision. This one is an important thing. Okay, and then parameters that typically change and whose change can influence investment decisions include investment cost, cash flow, residual value, interest rates, tax, tax rates, and so on. So this thing is done because the figures used in the calculation are estimates. So it's not exact value, of course. It can be estimates and projections. So the calculation output is relative, not exact. Never the feasibility analysis is never exact. Then the actual conditions often change, so anticipating any change is necessary. And then you want to identify the sensitive parameters or the parameters that alter the optimal solution when their values are changed. And this one is the target and sources of uncertainty. The target is to identify the impact of of data change on the optimal solution, and then to provide an answer to the question: to what extent are changes justified without changing the optimal solution, or without calculating the optimal solution from scratch? The sources of uncertainty includes possible inaccuracies in the estimates, then associated business risk, type of physical building and equipment used, and then the assumed time period. Next up is the questions and steps. For the question is which constraints can be relaxed or increased, and by how much is this relaxation justified? Thus increasing the Z-score without having blah blah blah, blah and so on. It's mathematical language, so I don't want to go further into it. Then which constraints should be prioritized for relaxation, and by how much can the objective function coefficients can be justified without changing the optimal solution. For the steps here, we need to determine the factors that are most likely to vary from the estimated values, then select the range of possible variation for each vector, then choose an economic evaluation method for the present value, future value, annuity, or rate of return for each vector. Then calculate the values based on the vector variables, and then create a diagram if necessary. Okay. For the same case, we want to do the sensitivity analysis. Hmm, okay, so this first one is the example for the sensitivity of the discount rate. Okay, so we get this L equals to 12% per year. Then I use difference of 10% relative to this one. So uh, I add 1.2% to here, 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 and here. Then and then subtract it by 1.2% to here, 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 and here. And this variation is up to you, whether you want to use difference of 1%. So for example, this one is 11%, this one is 10%, this one is 13%, this one is 14%, or difference of 2% maybe. So this one is 10%, 8%, 6%, this one is 14%, 16%, 8%. It's up to you. Okay. But just remember, if this question appears on your exam, don't don't calculate this many, okay? Because basically for this thing you need to recalculate the NPV for this this many. So just limit uh, just limit the variations according to your time of the exam, according to your duration of the exam. Don't make this many on the exam. Okay. So we can plot this thing into this graph, and then we can conclude that the graph, the discount rate in the increase of the discount rate uh, will yield into the decrease of NPV non-linearly. Okay. This one is the example for the variation of analysis period, and the values given is 10 year, and we calculate for other years. And this is also non-linear, the result. But if you see here, every 3 years, the graphic is some kind of broken here, here, and that's because logically is because the 3 year periodic maintenance. Okay. I use this formula here for the Excel formulation. No need to bother about it. And this one is the example for the variation of investment cost. And this graphic is linear. The increase of the investment cost yield into the decrease of NPV linearly. Okay, that's for the third tutorial.